Let's go to LeetCode 983, minimal cost for tickets. So it gives us integer array days and also integer array costs. So there are three types of tickets, and one ticket it can last for 1 day, and it use cost $0, and another ticket has can be used for 7 days, and it use cost $1, and the the other ticket has can use to cover 30 days, and it has cost $2. So we want to cover all of the days. For example, um, in this days array, and um, trying to use a minimal cost. So we know the worst case, right, is that for each day we use a cost for the tickets which have 1 day pass um, for each day. So, uh, so, but sometimes, for example, we can use some days which can cover 7 days or 30 days, right? For example two, right? We can buy one ticket which cover for 1 day, and another ticket which cover for 30 days. That is the minimal cost. So it will cover all of these days. So for this question, actually, what I was thinking about is that we can think about using the DP approach, right? So we know every DP, if there is days, right? Um, if there is days, it will be the DPI minus one plus cost zero, and I minus 7 plus cost 1, right? And I minus 30 plus cost 3. We want to find the minimum of this. And then in the end, we just want to find, for example, the max days, the DP max days, right? So, um, intuitively, what we're thinking about is that we can have a DP which have an array will be the max days plus 1, right? And we just iterate day by day. And if for one of the day, which is happen to be appears in this I, right? We should at least use a 1 day pass. But we can also coming from using the other two tickets trying to see whether it will be minimal, right? So if we, so we can do the approach to have a DPM, right? Doing like this uh, was a because we are going to for loop from I to the maximal days, so it will be linear. Time complexity will be OM, right? And in the space, because we have DPM, that will also be OM, right? Another approach is that if these days, for example, the days they are very sparse. For example, if the maximal days is very big, for the maximal days will be 10 to the power 9, right? But this days array itself is very small. For example, it has only 100 days, right? In that case, we can use a tree map. Instead of go through day by day, right? We just we go through every day in this, trying to find its day minus one and day minus two and day minus seven and day minus 30 flow key, right? So we'll ask what's the range for this kind of days array. If this is sparse, And the largest value is very big. We should use a tree map or binary search, right? To do the tree map, the time complexity will be n log n. It will depend on the length of the days. And if we want to do DPM plus one, the complexity will be linear with the maximal days, right? So we are going to write two approaches. For this question, you'll see the days length is smaller than 335, and also the DI is smaller than 335, right? So both approach will work. Um, but in case, for example, this one, the maximal days may be a very big one. In that case, but we may use a tree map depending on what the first array looks like, right? I'm going to use two approach. First one is we use a tree map integer, and we're going to have an integer. We call tree map equals new tree map. And because we want to find the floor key, right? So we can put we want to for every day, right? We want to find a floor key of I minus one, I minus seven, and I minus 30, right? So we can always put for example, put this one, put minus 31, right? So that we always find the floor key of this. So what we do is for int d in days, we are going to have int v1 equals tree map below entry d minus 1 get value plus cost 0, right? Cost 0. And we also have int v2 equals tree map below entry d minus 7 get value plus costs 1. And also we have int v3 equals tree map of floor entry d minus 30 that get value plus costs 3, right? So for every current day, right? What we want is we want to map put d in math.mean d v1 and math.mean v2 and v3, right? So in the end, what we want is just want to find the last key, last entry of the value, right? Return tree map dot last entry dot get value. So doing like this, that the time complexity will be depend on the length of the days, right? So it will be n log n, right? So if not dependent the exactly number, but if we for this case, you will see the day this I is always smaller is equal to 335. So we don't need actually we can also not use a tree map, right? We can just use iterate the days day by day. Doing like that, it will be linear of the maximal days of time complexity, right? So we can have an int j, which is initially the days, the index of these days, right? So initially it is set as 0, and we have n equals days dot length. So we are going to have actually we may not need n, right? So we are going to have, for example, int m equals days dot length minus 1, right? So we are going to have int dp equals new int m plus 1, right? So what we do is that for int I equals 0, I smaller than m plus 1, I plus plus, right? So let's see, dpi, well, first coming from dp, um, um, dpi minus 1, right? Because we so that will be consecutive. We are want to calculate it will transit from the previous one. But in case this day appears in the days array, for example, if we have j smaller than n and days j equals I, right? It happens in the days array. We can have interval one equals dp I. Let this one coming from previous one. Let's say I is from 1, right? And this one will be I minus 1 plus costs 0. And the int v2 equals dp I minus 7 plus. So, but the thing is that it may be out of bound, right? So that is, if it is out of bound, we can do max, but max 0, right? dp0 will always be 0, right? And plus costs 1. And also into v3 equals dp max dot max 0 I minus 30 plus costs 2, right? So if this one, we're going to have dpi equals max dot mean v1 max dot mean v2 v3, right? And we also need to move the J index in the data array. And in the end, we just return dpm, right? We let's still have n out, right? N is days dot length. Okay. We can also write the code in Python. We can also write the two approaches. So let's first have use a tree map. The in Python it is called ordered state, right? So dp equals ordered state, and we're going to have put a dp minus 31 because there, so that we are always find the floor key, right? The floor key is by binary search right um, minus 1, right? So what we do is that for d in days, we're going to have keys. Mm, we need to have a keys equals a list of dp dot keys, and we're going to have in ID1 equals bisector right. So keys d minus one and minus one, right? This is find the index, the which is the right of the index, right? And and also we want to should minus one, because that ID is the place which it inserts. So this will be the last index smaller equal uh, to to um, this kind of d minus one. And we're going to have V1 will be dp keys ID1 um, plus plus 0. Um, and we're going to have ID2 equals bisect bisect right is d minus 7 and minus 1, right? So we'll have V2 equals dp is ID2 plus 1, right? And we'll have ID3, which is bisect right is d minus 30 minus 1, right? So V3 equals dp is ID3 plus 2. And we're going to have dp d equals mean v1, v2, v3, right? In the end, we just return dp. We can use the next reverse reverse dp, right? Like this will be the last one. So we can also write the linear max approaches. That will be easy. So we're going to have j n equals 0 and the length of days, and m equals days minus 1, right? So we'll have dp equals this one multiplied by m minus 1, right? For I in range and platform. Then we have dpi, which is well coming from dpi minus one, right? And if happen this I is pairs in this data array, right? Then let's say if j is smaller than n, and this j equals I, then we'll have v1 equals dp I minus 1 plus costs 0. Let's have this one from 1 to this one, right? So that this one not be minus 1, right? So we have v2 equals dp uh, max 0 I minus 7 plus costs 1, and the v3 equals dp max 0 I minus 30 plus costs 2, right? So we'll have dpi equals mean v1, v2, v3, right? So we can move in the j-index in the data array. And then in the end, just return dpm. This will be plus 1, right?